So good afternoon to all. I welcome all the participants for AICTE-sponsored STTP on research challenges and applications of Internet of Things in Smart Agriculture for Day 5, Session 2. It's pleasure to welcome our resource person, Mr. T.N. Raj Vignesh, Chief Technical Officer, Sally-Apps Electronics Engineers LLP, Salem, on the topic of real-time scenario of IoT in agriculture using LoRaWAN. Welcome you, sir.
Thank you, sir. Thank you. So should we proceed now?
Yes, sir. Sir, there is already one participant asked a question, sir.
Okay.
Actually, sir, is it possible to introduce IoT technologies in libraries to provide library service to our user at their home place?
Pardon, can you repeat the question?
Is it possible to introduce IoT technologies in libraries to provide library services to our user at their home place?
Okay. Well, we need to think about this. Already, IoT has been implemented in libraries for bookkeeping, book management. But in the current prevailing scenario, I understand you want to offer library services at home. Maybe let me think about it and get back to you. I haven't thought in this angle. What we have done for libraries already is we have put RFID based IoT technology. So the moment a book is being carried inside the library or taken out of the library, we will know that it has moved in or moved out. So we will know whether it is there inside the library or how many copies of the book are there. So to that extent, we have implemented IoT, and we have also gone to the extent of employing face recognition cameras at the entry and exit of libraries to see who carries what book outside. So instead of having a library card or a separate software that will maintain who borrows what book, automatically it is recorded. To that extent, we have done. To the extent of offering library services to people who are not coming to the library, the first step would be to digitize the library. Or maybe we'll have to have a discussion with the person who asked this question. Can you unmute the person so I can have a discussion with him?
Yes, sir. We unmuted him, sir.
Okay.
Hello.
Hello.
Sir, good afternoon, sir.
Good afternoon.
Sir, my name is Dr. Anjay, Assistant Professor in Libraries.
Okay, sir. Okay.
Since it started today, I am very happy with your technologies, especially you are using in agriculture sector.
Okay.
At the same time, shall we use the same IoT at our users' desktop or their home place? Because the COVID-19 pandemic, there is a need to provide at least reference services or ask librarian services. Can we use the user must the user may be at their home, we are in our libraries.
Okay.
If they put any question to us, shall we give the answer?
Okay, this is definitely possible. But how do you want to, so you only want to give them excerpts of the reference. You don't want to send them the books, right?
So possible, I have seen somewhere, sir, when attending the webinar, they are using drone technologies to issue the books at their home. But in Indian context, it is not possible, sir. It is possible at a Western place.
Yeah.
In Indian situation, it is highly impossible as by my knowledge.
Yeah, definitely. So what do you expect out of IoT? You want to deliver the books or you will respond to them on their request? So you will refer the books and give them some references
By
from the
request
books.
only, sir. By request only. Is it possible to provide the books at their home?
Okay. And then get it back, right?
Okay, sir.
Yeah,
Yes,
this
get it
is,
back, sir.
yeah, this is definitely possible.
Sir.
We will talk about, some protocol called MQTT in this session. Okay.
Sir.
Using MQTT, we can build a chat box, okay, between the library console and the users. So
Sir.
we can have web and mobile applications integrated. And we with the help of RFID stickers pasted on the books in the library, we will
Sir.
also know whether that particular book is there inside the library or somebody else has physically borrowed it.
Sir.
So then when somebody places a request for a specific topic or a specific subject, then we will get that request on the librarian's console in the library. Then
Sir.
he will go with a handheld scanner to scan the library, that particular place, to see whether that particular specific topic or that particular book is available in the library. So if it is there in the library, he can specifically spot where that book is and he can take that book out. Then further reading the content of the book and sending it to that person can either happen on the chat box itself or it can happen offline through mails.
Sir.
This is an idea that I can suggest. With the help of IoT, you can automate or digitize your library.
Sir. Okay. Thank you. Thank you, sir.
Thank you, sir. Thank you. Is my screen visible?
Yes, sir, it's visible, sir.
Just brushing up on what we saw in this forenoon session. We went through what is IoT, what, why, how, and where question templates were applied on IoT and the responses were seen. The architecture of IoT solution, components of an IoT solution we saw as the nodes, the network infrastructure, the gateways, and the backend, which is called the cloud, and the data center. And finally, we have the mobile and web applications for analytics. Two types of architectures we saw. One is a simple gateway, other one is the edge computing gateway. The necessity for edge computing gateway and where a simple gateway can be deployed and where an edge computing gateway has to be deployed. Advantages of using an edge computing gateway and advantages of using a simple gateway were all seen. We saw what is a typical gateway, what are its inputs, what are its outputs, what kind of sensors can connect, and what kind of output options we have. Hybrid architecture of gateways were seen with the simple gateways and edge computing gateways. We saw some of the IoT gateways, simple IoT gateways. Some of the products we have seen. We saw some use cases of using it in factories also like this. One safety use case we saw like this. Then we went through the sensor options, all the different kinds of sensors and possible sensors that are used in IoT were all explained here. And for one example, in living room, in houses, we saw one example of IoT transmitter, IoT node with relative humidity, air quality sensor, ambient light sensor, and temperature sensor connecting on Wi-Fi, LoRaWAN, or RF or Bluetooth. For office spaces, we saw human occupancy inside room, in and out tracking. For home safety, we saw magnetic door or open close sensor connected on Wi-Fi. We also saw indoor home garden soil moisture, ambient air moisture, and ambient temperature sensor current consumption sensors for high current consuming electrical appliances, different kinds of gateways, simple gateways and edge computing gateways with the interface options we saw, battery operated, line operated, different connectivity options and all were seen. Two different types of IoT network model, M2S model, which is machine to server. Directly the nodes will transmit data to the server without intervention of any other hardware. That is M2S model. M2MTS model we saw, where the nodes will send the data first to one hardware called the gateway. Gateway will collect data from all the nodes and forward that data to the server through cellular tower. We saw the advantages and disadvantages of both the models, and we also saw applicability of these models in different use cases. We went through a small workshop also explaining how to position a solution, where to employ what technology, where to choose what model, what architecture and all that. So with that understanding, now we have seen that in this segment, we all know very much about the M2S model, which is based on GPRS or 3G or 4G. So this second session, we are going to concentrate more on the M2S model, which is LoRaWAN. Under M2S model, we have RF and Bluetooth and LoRaWAN. RF, Bluetooth and LoRaWAN, three technologies we have. But for today's session, we are going to limit the discussion to LoRaWAN, which is very new technology, very new topic, very much happening nowadays. So this is the typical architecture of a LoRaWAN network. You have the nodes, which are the LoRa nodes. Then you have the LoRaWAN gateway. And you have the another software component called LoRaWAN gateway server. This is an extra software component before sending the data to the data center or the server. So in M2MTS model, what we have seen prior is the data will come from the nodes to the LoRaWAN gateway, and from the LoRaWAN gateway it will go to the server. In LoRaWAN, the same technology is there, same architecture is observed as in M2MTS, except one additional software component is there. Hardware wise, it is M2MTS only. These are the nodes, which are the machines. Another machine called the LoRaWAN gateway. Finally, it goes to the server. But before going to the server, there is another process in the software that is called LoRaWAN gateway server. So this is the typical architecture. Nodes will transmit data to the gateway. Gateway will collect data from all these nodes and forward the data to the LoRaWAN gateway server. From the gateway server, data will go and get stored into the data center, from where mobile and web applications will fetch the data and show the data for analytics. Now, each LoRaWAN gateway can connect up to 2000 LoRa nodes like this. It can be anything. Any one node can be temperature transmitter, other node can be ambient light transmitter, other node is relative humidity transmitter. Similarly, you have air quality, soil moisture, location sensor. So it can be anything. Any data can be sent to LoRaWAN gateways, and the LoRaWAN gateway will collect all the data, compile all the data, and send it to the gateway server. This gateway server has three components called the gateway bridge, network server, and application server. Three subcomponents are there inside this gateway server. First, the LoRa nodes will connect with the LoRaWAN gateway. It's not like simple Wi-Fi where you mention the SSID and password of your Wi-Fi router and the client will get connected to it. It is not like that in this case. Here, for connecting a node to the gateway, you have to log into this gateway server and mention the MAC address of the nodes. Only then this node will get connected to the gateway. Though the LoRaWAN gateway has an SSID and password, it is not just enough for programming that SSID and password. In this LoRaWAN, it is not called as SSID and password. It is called as app security key and network security key. Two keys are there. If you just program the keys into these nodes, it's not enough to connect these nodes to the gateway. It is also mandatory to log into the gateway server and tell the LoRaWAN gateway that a node of specific MAC address will be attempting to connect with it. So in this way, LoRaWAN is very secure. It is not so easily hackable. You will have to provision the connection from the gateway server, not just taking the node into the connectivity into the coverage of the gateway. So these three components form the gateway server: gateway bridge, network server, and application server. The gateway bridge component is responsible for decoding the data being transmitted LoRa nodes to the gateway. The communication between the LoRa nodes and the LoRaWAN gateway is completely encoded in LoRa packet format, which is a specific and proprietary packet format belonging to Semtech Corporation. So this LoRa nodes, whatever data it is sending, it will encode in a format called LoRa packet format and send it to the LoRaWAN gateway. It is the first responsibility of this gateway bridge component of this gateway server to decode that message. Once a message is decoded, the network server is responsible for differentiating from which node it has come, because once the network server is there, the network server is responsible for two different actions. One is to establish the connectivity between the LoRa node and the LoRaWAN gateway. So it only knows what is each and every node, what kind of data every node will send, what is the MAC address of each and every node. So the network server knows everything about all the nodes. So once the message is decoded by the gateway bridge, the network server will classify each message belonging to which node. So it will classify, if suppose there are 1,000 messages being transmitted by 5 or 10 nodes, this network server is responsible for classifying which message has been sent by this temperature sensor node, which messages have been sent by this air quality sensor. So like that, it will segregate under each and every of these nodes. That's the responsibility of network server. Second responsibility of network server is to tell the LoRaWAN gateway by when the user is logging into the gateway server here and mentioning the MAC address of the nodes, it will tell the LoRaWAN gateway that such and such connection will come in, and it has to approve. So entirely the network server is responsible for two actions. One is maintaining the connection between the nodes and the gateway. The second responsibility is to group the messages being received by the LoRaWAN gateway under each and every node. Once the messages are grouped under each and every node, the application server will segregate that message into a readable format and forward that to the data centers or the server or the database. So this is the typical architecture of LoRaWAN. Here, additional component called the gateway server is introduced, and it sophisticatedly enables us to manage multiple gateways and manage multiple nodes under each gateway. So by buying a new LoRaWAN node, I can simply log into the web application of the gateway server and configure that particular node to a specific LoRaWAN gateway and mention the message format. So this way, we can simply keep on adding more number of LoRa nodes under the coverage of LoRaWAN gateway and just log into the web panel of the gateway server and mention that such a particular node will come and connect to this particular gateway. So it becomes easy for us to manage without going to the field, without having to connect the nodes to the gateway manually. Automatically, it can happen from the gateway server. So this is the typical architecture of LoRaWAN. Now let us go into the SWOT analysis: strength, weakness, and opportunities and threats. Before going to it, we should see from an IoT perspective, what is a strength, what is a weakness, what is an opportunity, and what is a threat. Before classifying LoRaWAN under this table, we will see what are strengths, what are weaknesses, what are opportunities, and what are threats. So now we will look at what are strengths. Strength of an IoT network is less number of components in the IoT architecture. So if you look at this architecture, M2S model, in this model, if you see the components are very less, there is a node and there is a server. The GSM architecture, the cellular infrastructure is already well built. So the risk is very less and it is the strength. But that the risk is very less. But the weakness of this M2S model is every node has to be individually managed. Every node needs to have a SIM card. It has to be individually managed. So this is called a risk. Opportunity of M2S model is we see that it can be deployed outdoors in any different spread across the nation. It can be deployed. But when it comes to threat is once the GSM network is down for some time in a particular area, you will not receive the data. So likewise, we will classify the LoRaWAN technology also under the SWOT analysis. The strengths being long battery life of the nodes. As I was mentioning, in M2M2S model, usually the communication between the LoRa nodes and the nodes and the gateway will be of radio frequency. Because it is of low power radio frequency, these nodes can operate on battery for longer periods of time, even years together. So that is the strength. Another strength is the less running cost, because if you see, there is no cost of data for transferring data between the LoRa nodes and the LoRa gateway. The third strength is one-point maintenance of all gateways from the network server. As I was mentioning, you can maintain any number of nodes and any number of gateways from this gateway server by a single login. So instead of, whereas if you see in this M2S model, each and every node has to be connected to this GSM network, and appropriately it has to be managed separately, individually, hardware-wise. Whereas here, you just have to log into the gateway server and everything can be taken care from there. Weakness is, if you see, there is one more additional component called the gateway server is involved here. So this is seen as a weakness. In IoT network, less number of components, more stable the solution will be, is the belief. So introducing another component here is giving us a risk here. So that is seen as a weakness. Gateways are required. Yes, in M2S model, the infrastructure is already there. Whereas here in M2M2S, which is LoRaWAN, we need to install the LoRaWAN gateways, which is our scope of work. Maintenance of network server. This gateway server, or otherwise called as network server, is a software piece that has to be reliably run on the cloud. That is also our responsibility. So running the network server or gateway server is seen as a weakness. Firmware over the air updates for nodes is very challenging. If you want to update the firmware or behavior of these nodes, it's not possible to push that update from the gateway server or through the LoRaWAN gateway. You have to go to the field, capture every node individually and update the firmware. Backhauling from gateways to network servers to be done over Ethernet or Wi-Fi or LTE, because there are too much of data that will come to the LoRaWAN gateway, and because this LoRaWAN gateway is a simple gateway, it's not an edge computing gateway, it's a simple gateway. Too much of data will come to this LoRaWAN gateway. So we need to have reliable high-speed data connection like 4G or Ethernet given to this gateway. Otherwise, data coming to the gateway server and to the data centers will be delayed, or sometimes the data might be lost also. Limit of 2000 nodes per gateway. In M2S model, you can have millions and millions of nodes in the field. There is no limit. As long as you can maintain so many SIM cards, you can manage so many nodes. But here in LoRaWAN, you have a limit of 2000 nodes per gateway. You cannot connect more than 2000 nodes per gateway. Opportunities is, it is very strong applicability for outdoor use case and for a contained area. So within a given area, if you have too many number of nodes, it is the LoRaWAN finds the best opportunity there. Secure latching between the nodes and gateway through activation based on personalization and over the air activation. So there are two different kinds of activation between the nodes and the gateway, which is called ABP, activation based personalization, and OTAA, over the air activation. So using the app security key and network security key, a node will comfortably connect to a particular gateway. Threats are dependency on network server provider for LoRaWAN version upgrades. Failure of gateway leads to loss of connectivity. So if you look at this architecture, this LoRaWAN gateway server is a software piece and it is running on the cloud, and the software is being provided by couple of players in the market. So we have to rely on them for this particular component. Currently, this gateway server is being offered by two companies, TTN, The Things Network, TTN, and ChirpStack, CHIRPSTACK, ChirpStack. Out of these two, ChirpStack is open source and free, but it has very less community support. Whereas TTN is commercial, it costs a license to run it. It is well supported by the TTN company itself. Failure of gateway leads to loss of connectivity. So once this gateway fails, totally the network will crash. Here, one of these nodes fails, the remaining nodes can communicate with the gateway and send the data. So if either the LoRaWAN gateway or the gateway server fails, completely the entire solution will crash and it will not work. So that is a threat of the LoRaWAN. So with that, we are done with the introduction of LoRaWAN. If you have any doubts, you can ask me right now. Before we proceed to live demonstration of how to configure a LoRaWAN gateway, if you have any doubts, you can ask me. Post that configuring LoRaWAN gateway, we will move to MQTT protocol, and we will demonstrate how to use MQTT protocol, how we can communicate with each other over MQTT protocol, how IoT nodes can communicate within themselves without the help of gateways over MQTT protocol. So now you can ask me.
Dear participants, if you have any doubt in the SWOT analysis, you can ask now.
Okay, let's proceed. So what you are seeing now on the screen is a LoRaWAN gateway that we built ourselves using Raspberry Pi. And there are other LoRaWAN gateways that are available in the market as well. We will see some of the products right now. This is a small LoRaWAN node that we built around a small microcontroller called Atmega 328, which is found in Arduino. So this is a small board which is measuring around like 5 centimeters cross 5 centimeters. You can program this board in Arduino. It has this LoRa module here. You can see there is a provision to connect an external antenna also. So this is another product that we have under this LoRa segment. Now we will see some of the products that are available in LoRaWAN gateways. So this particular company is very renowned for manufacturing IoT gateways, LoRaWAN gateways. There are too many variants that are available. You have indoor LoRaWAN gateway, you have outdoor LoRaWAN gateway, you have sometimes even portable LoRaWAN gateways are available with these people. You can choose one among them based on the kind of coverage, based on the kind of power supply required, the price of the LoRaWAN gateway will start from, say, about like 15,000 to it even goes to like 3 to 4 lakhs. So if you want a city-wide coverage, you must consider employing a LoRaWAN gateway of like 3 to 4 lakhs. Otherwise, you can go for if you are using for hobby purpose or research purpose, you can go for indoor LoRaWAN gateway, where it has very less coverage, say about like few meters, and you can use that for demonstration of your things. So this is the LoRaWAN gateway here. So as I was mentioning, now we will go through the gateway server. We are using this one called Chirp Stack. So this is an open source LoRaWAN gateway server. So as I was telling, it has 3 components: the gateway bridge, the network server, and application server. You can download the installations here. You can see the instructions here for installation. Just give me a second. I'm getting back-to-back calls. Just a minute. Yes, I'm back. Sorry for the disturbance. So as I was mentioning, the network server has 3 components: the gateway bridge, the network server, and application server. This complete suite of software is given free of cost, and it is open source. You can go to the download section. Here they have given you complete instructions on how to install it. So what we have done is we have taken a virtual private server, Ubuntu server, and followed the instructions in this page. You can see the instructions here. Follow each and every command carefully. You can even install it on an Ubuntu system, not necessarily a virtual private server, and run this network server. So we will directly log into the installed image of our gateway server. These are the UI screens. You can monitor the number of gateways. You can have different instances of network servers. You can have multiple organizations. More applications can be built on top of it. So we will directly jump into the installation of the gateway server. Means configuring the gateway into the gateway server. So when you log into the gateway server, you will get something like this, which is a login screen. You will have to put the username and password you created when you installed the gateway server. When you log in, you will be directly taken to you will be directly taken to the gateways here, to the dashboard. You can see the kind of number of gateways that are there, number of gateways that are active right now. Currently, there are no active gateways. So when you want to add a new gateway, click on the gateways, click on create. You will be prompted to give a gateway name. You can give any gateway name and description of your own. When you buy a gateway, just like when you buy a Wi-Fi router, an address or serial number will be written on top of it. Similarly, here also, a gateway ID will be written on top of it. You will have to enter that gateway ID here. And finally, when you click create gateway, the gateway will be added. So we have already added 3 gateways. 2 of them, 1 day ago, we have seen the pings from these gateways. Now we have, in the last session, I had created this gateway also similarly. So we will try to create the gateway right now. So go into the gateway section, click on create new gateway, give a gateway name. Let me give it as test gateway. You can give any description. Enter the gateway ID. Select the network server, which is localhost. Click on create gateway. A gateway has been created here. Now to add the nodes into this gateway, click on applications, go into the gateway that you have already created. Every LoRa node will have a unique MAC address called EUI. So you have to note that EUI. This chip, when you buy the LoRa chip, it has a specific EUI for itself. You have to note that EUI down. Click on create. Give it a device name. So I will call it as humidity 1, humidity sensor. Enter the device EUI. Click on create device. The device has been created. So you can go and give the activation keys here. As I was mentioning, for the keys, you can mention you can either go for OTAA or ABP, activation based on personalization. So when you create the LoRaWAN node, it will generate a network security key and app security key also. You will have to enter that network security key and app security key here, and finally click on activate the device. It will finally activate the devices for you. So now you see we have 2 nodes under this particular gateway called Pongonadu. We have K1 and humidity 1. So once this is done, the nodes will start communicating with the gateways appropriately. Now we will go into the applications. Unfortunately, we don't have the gateways live now. Otherwise, I can show you the live frames. So these are the devices that are already there linked to this particular gateway. If you see, about like 32 nodes have been connected to this particular gateway. So with that, the data will come into this gateway server. When you click on the gateway here and click on live LoRaWAN frames, here you will be able to see the live frames coming in. Unfortunately, we don't have the gateways here operational right now. For some reason, they are offline. So I'm not able to show the live frames coming here. So the live frames coming here will be segregated by the third component of the gateway server, and then it will be forwarded outside. Once the message is forwarded outside, it has to be received in a database, and that can be done here. If you go into the integrations, you have different options for transferring data from here to some other database. You can have an influx database account. It will be directly inserted into the database, or you can write a HTTP RESTful JSON API, or you can send the data to your AWS server also, Azure, ThingsBird. So something like this, you have different kinds of integration options here. You can forward the data from here to the application server. Once it is there on your application, on your database, you can build your web and mobile applications on top of it to view and perform analytics on the data being transmitted from the LoRaWAN nodes. So with that, we are coming to the closure of onboarding and configuring a LoRaWAN gateway and onboarding and configuring nodes to the LoRaWAN gateway. If you have any doubts right now, I can re-demonstrate this. You can ask me. Okay, let's proceed. So the second part of this session will be on MQTT protocol. So we will now get into a small interactive session as how we did this morning. So I want the attendees to help me to fill up this thing. I would like to know the kind of internet communication protocols that are available. Internet communication protocols like HTTP, please name a few. Some other internet communication protocols like HTTP, what else? HTTPS and SMTP, okay. You can raise your hand and the host will unmute you. It becomes less engaging to see on the chat and then respond to you. It can be a live session. Maybe we can unmute everybody, and those who want to mute themselves, they can mute themselves. Anybody else? Somebody has raised hand. Please unmute them.
IMAP?
Hello.
Yes, sir. IMAP?
Your voice is breaking. Hello.
Yes, sir. IMAP?
Pardon?
IMAP.
IMAP. Okay.
And there is something like a FTP. Through that also we transfer files.
Yeah. FTP.
Right.
What else? TCP. UDP. These are something very preliminary, and we've been operating on it for ages. TCP, UDP, FTP, SMTP, all that. Okay. Fine. Okay. So now we will categorize the protocols, internet communication protocols, under these 5 topics right now. Or maybe we will not talk about SMTP and IMAP because it is not relevant for IoT, because it's simple mail transfer protocol. We will not transfer mails between IoT devices. So we will keep it crisp with this HTTP or HTTPS, FTP or SFTP. That's okay. S means secure, means you will just add an SSL certificate on top of it. TCP and UDP or WAP. So we will compare. We will study the contrast between these only for now. Okay. Now I want the attendees to help me to understand before we fill up this table as workshop. Can somebody tell me what is HTTP? In HTTP, what are we transferring and how the transfer is happening?
Are you asking the expansion of it?
Yes, I'm asking the response.
Okay.
What is HTTP? What is your understanding of
Transfer
HTTP?
protocol.
Yes,
Hypertext transfer protocol, sir.
hypertext transfer protocol. So we transfer text.
Correct.
Okay. Is there a limit on the size of the text that can be transferred in HTTP?
I'm not sure, sir.
There is a very small limit. It doesn't allow huge amount of data to be transferred. What about FTP?
FTP is a file transfer protocol. There is no limit for the size of the file to be transferred.
Yes. In HTTP, can I transfer a CSV file or TXT file? No.
Okay.
Fine. What is the difference between TCP and UDP? What is the difference between TCP/IP and UDP? Anybody? TCP/IP and UDP. UDP is user datagram protocol. Somebody has raised hand.
User datagram protocol, TCP's transmission control protocol.
Okay.
So in the TCP, we need a connection oriented.
Okay.
Three-way handshake method you have to follow in TCP. But in the UDP, there is no need of acknowledgement. You can transfer.
Exactly. So the purpose of me drawing this table now is to see why HTTP and FTP or TCP is not applicable for IoT. Now we will introduce you to one more protocol called MQTT. Before filling this up, before going to MQTT, we will try to fill up the rest of the columns. See, when it comes to Internet of Things, the complete system has to be lightweight. The complete data transfer, the connection between the nodes and the gateway, or connection between the nodes to the server directly, as in case of M2S, has to be lightweight. So we need to choose the protocols also accordingly. So we need to see that we need to ensure that there is no specific connection, long time connection between the node and the server, because if it has to stay in the connection forever, it means it is going to consume more amount of power and energy, which is not at all the use case of IoT application. So IoT application has to be characterized by low power, long battery life, so everything has to support it. So we have seen how M2S plays a role in battery life, determining the battery life of IoT solution. Now we will see the choice of protocol that one has to make to ensure that enough battery life is there for the IoT nodes. So we will talk about connectivity. Few parameters are there. Let me copy it from the presentation. We will take it up here only. So now we will talk about TCP/IP, UDP, or CoAP, and MQTT. CoAP is Constrained Application Protocol, which is a derived version from UDP. The only difference is the size of message is reduced in CoAP, and the CoAP is meant for running on constrained hardware like embedded systems hardware. So we will, as how we did this morning, we will now do this workshop on these six topics or six parameters. Type whether TCP/IP is connectionless or connected. Whether TCP/IP is connectionless or connected. Connectionless means if the server and the client are connected always, or it is connectionless. Anybody? The client and the server are connected permanently, or it is connectionless.
It's a connection oriented, sir.
Yes, it is connection oriented. UDP?
Yes. Connectionless.
It's connectionless. Meaning the TCP IP, the client is to be connected to the server always, whether it is sending a message or not, it has to stay in connection with the server. Once it loses connection with the server, again it has to re-establish its connection with the server. So that is why it is called as connected. Whereas in UDP or constrained application protocol, the client need not, or the node or the client need not be in connection with the server always. It needs to be in connection only when there is a message for it to be transmitted. So when there is a message it wants to transmit, it will simply connect to the server, transmit, and then disconnect from the server. The next method, the next parameter, handshaking. Is there handshaking between the client and the server in TCP/IP? Handshaking means the client and the server needs to know each other before transferring data. So it has to send a message, there should be an acknowledgement, and then only the actual payload will be transmitted. So is handshaking present in TCP/IP?
Yes, sir. Yes.
Yes. In UDP?
No need, sir.
No.
There's no acknowledgement.
Yes. Latency. What is the latency comparatively between TCP/IP and UDP? Which one is faster?
UDP only faster.
Yes. Client connections are to be maintained in TCP/IP. Should the server maintain the connection with the client?
Yes, sir.
In UDP?
No need to maintain.
Not maintained. Should there be a unique client ID for the clients to connect to the TCP/IP?
Yes.
Yes. In UDP?
Yes,
Client
sir.
ID is not mandatory. It's there, but it's not mandatory.
Okay.
MIMO means multiple input, multiple output. So when we talk about TCP/IP, can one client connected to a TCP/IP server send messages to other clients connected to the same server? I am a TCP client connected to the server, and there are 5 or 10 other clients connected to the server. Do you think I can broadcast my message to all other nodes directly, all other clients directly in TCP?
Yes, can send with the help of port number of server, right? I'm not sure, sir.
I can only send a message to the server, but can I send messages to other nodes, other clients also connected to the same server?
No, sir, no.
Not possible. Is it possible in UDP? Is broadcast possible in UDP? Broadcast by a client
Yeah,
possible
it's
in UDP?
possible.
No,
Broadcast
it
is
is
possible.
not possible because it's absolutely connectionless. Client
Yes,
connections
sir.
are not maintained. Even in a maintained environment, client connections are maintained environment. One client cannot directly approach the other client. It has to request the server, and maybe the server will have to forward it to the other clients. Here, this is client connections are unmaintained environment. Even the server does not know how many clients are there alive at any point of time. So how will one client know whether another client is alive and send a message to that client? So broadcasting or direct connectivity between one client to the other is not there. Reliability, which one is more reliable, TCP/IP or UDP?
TCP/IP, more reliability.
Yes, because it is connection based. So now if you see this table, we have to look at all these parameters. All these parameters decide whether these protocols can be used for an efficient IoT application or not. For example, look at the type, connected or connectionless. Which one do you think is preferable for an IoT network? Should the clients be should be maintained connected, or connectionless is better for IoT? We've seen all applications of IoT now. The question here is whether it is preferable to have a connected network between the client and the server, or it is preferable to have a connectionless connectivity between the client and the server. Anybody?
Connectionless is suitable, right, sir?
Exactly. Connectionless is suitable because to maintain the connection, both the client and the server need to spend some energy and spend some battery. So the energy level of the battery will go down. So connectionless is better. We'll talk about handshaking now. Is handshaking preferable or no handshaking is preferable?
Comes under connectionless means there is no need of the handshake method, sir.
Yes. So no handshaking is preferred. Latency should be high or less? Delay in transmitting a message is high or less?
Less only.
Less is preferred. I'm sorry, this has been entered wrongly. Latency is less in TCP/IP because the connection is maintained. The connection is well maintained. The connection is well maintained here. Whereas in UDP or CoAP, the connection is not maintained. So first it has to attempt connection. For every message the client will transmit to the server, first it has to attempt the connection. Only after attempting it will get connected, then only it will transmit the message. For every message this is going to happen. So latency is high in UDP and CoAP. So latency has to be less for IoT. Otherwise, if it takes a lot of time to just get connected to the server, then battery life of the node will drain. So latency less is preferred. Client connections maintained is preferred or not maintained is preferred? Client connections maintained is preferred because only then the server or anybody will know who is the client, whether the client is connected or not. Otherwise, we will never know whether a IoT node is alive or the battery is dead, whether it is connected, not connected. We will not able to be monitor at all. Unique client ID, this is not our concern. It is the concern of the protocol. But anyways, unique client ID, if it is there, it is better to address the client. So unique client ID is preferred. Multiple input, multiple output we need, because sometimes in IoT, if we are going for an IoT sensor network, the nodes or the sensors will communicate with each other. So we definitely need multiple input, multiple output. MIMO support is required, but unfortunately both these protocols don't offer it. Reliability, this one is high, this one is less. So TCP/IP is more reliable and it is preferred here. So if you look at the structure right now, TCP/IP has more advantages and UDP has less advantages. But the only problem that it is a connected network and it will drain more battery by handshaking and staying in connection makes TCP/IP completely unusable for IoT. But if you see, feature-wise, it has more number of advantages here than UDP and CoAP. So what people did is they wanted a trade-off between TCP/IP and UDP or CoAP. Then they went for this new protocol called MQTT, which is called Message Queue Telemetry Transport. This is a very simple protocol, very beautiful and very powerful also. Here we have a key component called the MQTT broker, which is a software component which can be installed on any IoT gateways, edge computing gateways, and simple gateways also. So this MQTT broker is just acting like our newspaper agent. So if you cleanly observe how newspapers are getting delivered to us, I have a newspaper agent in our area. He can be assumed as the MQTT broker. So I go to him and I subscribe for the Hindu, and my neighbor subscribes for the Times of India, and the other neighbor subscribes for the Deccan Chronicle. So what happens is, whenever the Deccan Chronicle or Times of India or the Hindu publishes a newspaper, I get my subscription only. I'm not getting my neighbor's subscription. My neighbor gets his subscription only. He's not getting my subscription. Suppose tomorrow I subscribe for one more newspaper. Today I've subscribed for Hindu. Tomorrow I'm subscribing for Times of India also. From tomorrow onwards, I'll receive both Hindu and Times of India. Again, if I go and unsubscribe to the Hindu, the next day onwards, I'll stop receiving the Hindu. I will only receive the Times of India. This is the same work being done by the MQTT broker. Here, instead of the newspaper names, the publisher names, we have something called as a topic. So there are nodes on the left-hand side and there are subscribers on the right-hand side. So here, anybody who writes a content to the topic is called a publisher. Anybody who wants that content is called a subscriber. So here there is no concept of client and server. Everything, the central point is the broker. Everybody else is seen as the node, MQTT node to this MQTT broker. So now we will take this concept of different sensors connected to one MQTT broker, and this MQTT broker sending data to the backend database from where the data is being fetched by the mobile and web applications. We have three sensors. One is a temperature sensor, other one is a motion sensor, the third one is a moisture sensor. So now we have three topics: temperature, movement, and moisture. So these are the three topics very analogous to the Hindu, the Times of India, the Deccan Chronicle. Now all these nodes will publish or write to that particular respective topic. The temperature sensor will write the temperature data under the topic called temperature, and the motion sensor will write the movement data under the topic called movement. Moisture sensor will write its data under the topic called moisture. So they will keep writing the data, or the writing activity is called publishing. So they will keep publishing the data under a specific topic to the MQTT broker. So which means we have a topic and message being published, and in the subscription we only subscribe to the topic. So whenever somebody subscribes to a specific topic, now suppose this mobile application has subscribed to the topic called temperature. Whenever the temperature sensor publishes the temperature data, the mobile device will receive alert, just like receiving an SMS. Similarly, whenever the movement is being alerted or being published by the motion sensor, somebody has subscribed to that particular topic, they will get that particular data. So if you look at this, this architecture shows different publishers are there. There is a car, there is a light, there is a temperature sensor, which means different topics are there. They will publish in their respective topics to the MQTT broker, and there is a wearable, there is a watch, smartwatch, there is a mobile phone, and there is a server here. So whoever has subscribed to that particular topic, they will receive that message. If you have any doubts on this MQTT protocol, please ask me right now. Should we proceed? Now, having an understanding of MQTT protocol, now we will fill up this table. Is MQTT connection connected or connectionless? The connectivity between the broker and the clients or the nodes is connected or connectionless? Anybody? Nobody? It is connectionless. Because the broker does not care who is connected to it. It only waits for the subscribers and the published data published on that specific topic. So MQTT is connectionless. Is there handshaking between the nodes and the server, or sorry, the broker? Anybody? Is there handshaking between the nodes and the broker? Anybody to answer? There is no handshaking between the nodes and the clients. How is the latency? Latency is less because though it is connectionless, it doesn't care even whether the server is there or not, which means whether the broker is there or not. It knows the IP address of the broker and simply publishes to that particular broker. The publisher doesn't regard even whether there is a broker or not. So latency is less. Are the client connections maintained? Is my newspaper agent maintaining the list of subscribers? He should. Otherwise, how does he know that I have changed my subscription or I have subscribed to the Hindu? Yes, client connections are maintained. Unique client ID. So is there a unique client ID for the clients that are connected to the broker? Without knowing my unique ID, how will my newspaper agent be able to send specific newspapers to me daily? At least he should be knowing my door address, door number. So definitely unique client ID is there. Yes. MIMO, multiple input, multiple output. Is it there? Can one client directly transmit messages to the other clients? Please look at this architecture and tell me. Can one client directly publish messages to more than other clients? Anybody? Now this is a temperature sensor here, and it publishes the value called 20 degrees Celsius on the topic called temperature. The topic can be anything. It is user assumed. Okay. So it can publish on the topic called temperature. It is publishing the value 20 degrees Celsius on the topic called temperature. There is a web application. There is another computer. There are two computers. Suppose these two computers have subscribed to the topic called temperature. Will both of these receive this value 20 degrees Celsius, or only one of them receive? Anybody would like to answer? These two computers have subscribed to the same topic called temperature. Now, when this temperature sensor publishes the value called 20 degrees Celsius under the topic called temperature, will these two computers receive the message, or only one of them receive? Somebody has raised hand. Please unmute them. Host, please unmute Ponmoli Chelian.
It should deliver to both, if my understanding is right, because you don't know.
Yes, it will go to both. In fact, not only both, any number of nodes that have subscribed to the topic called the temperature will receive that message called 20 degrees Celsius. So it is not necessarily on the right hand side. It can be another sensor also. That's why I was telling MQTT allows sensor to sensor communication itself. So suppose there is another humidity sensor here. It publishes on the topic called humidity. Only this computer has subscribed to the topic called humidity. Only this computer will receive. So multiple input, multiple output is definitely possible in MQTT. Henceforth, now tell me, is it reliable or unreliable? How is the reliability? Reliability is high, because you see, whatever advantages are there between this TCP/IP and CoAP or UDP, everything has been covered by this MQTT. We want a connectionless network for high battery. We have that. We want no handshaking to conserve battery. We have that. We want less latency. Message should reach the server quickly. So that is only then the node will just transmit the message and go to sleep mode to conserve battery. That is there. We want the client connections to be maintained. Otherwise, we don't know whether a particular client is connected, alive, or dead. That is there. We want unique client ID to address specific messages to specific clients. That is also there. We want MIMO, multiple input, multiple output communication. We want the nodes to communicate with each other without having to wait for or requesting the server. That is also there. Finally, reliability. That is also there. Now you see, MQTT is totally summing up or covering up all the disadvantages that each and every other protocol is having. Whatever is the advantage between these two protocols, MQTT beautifully has taken into itself. That is why we are going for this protocol called MQTT. This MQTT broker, as I told, is a piece of software. It is available online and it is open source. You can visit mosquito.org. It's Eclipse based. You can download this software and install it on your system, or there is this thing called test.mosquito.org. Already people have hosted this online. You can go to that website here. You can use their server, test.mosquito.org. Now I request all the participants to go to Chrome plugin. Type on your Windows or MacBook or Linux, in your Chrome browser, type MQTT Lens. MQTT Lens. I want everyone to participate in this. This is going to be a live session. We will send messages to each other over MQTT broker. Just Google search for MQTT Lens and you will get a Chrome plugin here. I will send this link on the chat box to everybody. I've sent it on the chat box. You can click on the link and open it. Here you will find the install button. Once it is installed, you will see this button called Launch App. Please, all of you type installed after you have done the installation. Okay, one. What about others? Please type installed once you have installed it. Only one? If you have any doubts, you can ask me. I will guide you to install this tool. You can raise your hand and the host will unmute you. Have you installed? Please respond on the chat box. I'm waiting for your response. Only 3. Okay, let's proceed. So once you have done it, you will get the launch app button here. Otherwise, you can go to the start menu and search for the tool MQTT Lens. It will be there. Click open. You should see something like this. Are you able to see?
Yes, sir.
Yeah. Under this connections, click the plus button and a new form will open like this. You're getting it? You need to come along with me. If you have a problem, stop me. Otherwise, you will not receive the messages I'm sending and I will not receive the messages you are sending. As I had already told you, we have installed the MQTT broker on the cloud in the IP address iot.saliapps.in. I will send this also on the chat box. I have put on the chat box the IP address or the URL where our MQTT broker is running, iot.saliapps.in. Please copy, don't make a spelling mistake there, it will not connect properly. iot.saliapps.in. You will have to enter it here in the host name. You reach to this level, please respond as yes on the chat box. Okay. Let the port be 1883. Leave it as such. If you see the client ID here, the tool has generated its own client ID. You can again click generate a random ID. It will change. You don't have to change this client ID. The tool will take care of itself. Give the connection name, any name. I give it as test MQTT. Finally, scroll down and click on create connection. You see on the left hand side here, you should see this green color pause button. When you hover, it should tell us connected. Otherwise, if this is not coming, please stop me. You've done some mistake in the configuration. We'll have to correct it. Anybody is having a trouble, please raise your hand. I will help you out right now. Okay. Now you have two options. One is to subscribe to a specific topic here, then publish a message to a specific topic here. So publishing has two fields, topic and message. Subscription has only one field, which is topic. Now I request all of you to subscribe to a topic called name, N-A-M-E, all in small letters, lowercase, N-A-M-E. Enter the text N-A-M-E here and click subscribe. If you have completed this task, please type as subscribed in the chat box. Have you subscribed? Anybody else? Anybody is having a trouble, please raise your hand. I will help you out. Should we proceed? Okay. Now I will publish to the same topic as name, same topic name. I will send a message, which is my name. Have you all received that message here under your subscriptions? Please respond as received on the chat box. Anybody else has received? Anybody else has received? Now, if you look at the beauty of this, I only published under the topic name, but I received the message echoed back because I had already subscribed to the topic called name. So here the broker doesn't know whether who is sending, what it is being sent and all. It only knows who has subscribed to a specific topic. Whenever a message comes under a specific topic, then simply it keeps coming. So I received one message called Kumar because I've subscribed to the topic called name. Okay. Now you see I changed the topic of subscription and change it as my name. Now, although I have published, none of you would have received the message, or nor did I receive the message because nobody has subscribed to the topic called my name. So the topic is very, very important, including the cases, uppercase, lowercase, everything has to be taken care. Now, if I see again, I'm publishing. See, I've got the message now. So this is MQTT protocol. Any number of subscribers can be there for a particular topic. The MQTT broker only understands who has subscribed to what topic, and whoever has subscribed to a specific topic will receive that message. Now I will subscribe to a new topic and let you all to send a message to me. City is the topic I'm subscribing, CITY, city. So I all want you to publish your city under the topic called city. Maybe you're from Noida, you're from Thrissur, you're from Hyderabad. you can publish your city name under the topic called city, CITY, all in lowercase. You have to enter CITY under the published topic and enter your city name here. So somebody is from Bangalore or Erode. I received that message. Somebody is from Chennai. Somebody is from Virudhunagar. See, now I don't know each of you. We've never met. I don't know whether you are connected to the broker or not. You don't know whether I am connected to the broker or not. Just because I'm sharing the screen, you know that I'm connected to this broker on running on that particular URL. Once the MQTT broker is there, we all can communicate between each other without knowing each other. Just by having the topics, anybody can subscribe to any topic and anybody can publish to that particular topic. So this is what I suggested for the library automation also. So somebody can ask a question on a specific topic. Say, let's call it as electron devices is the topic. Somebody can ask any question. And publish it. Whoever has subscribed to that particular topic called electron devices will receive that. Now, in the library application software, we will have to create a list of subscriptions for these topics. So we have to create a list of topics of all the engineering sections and then subscribe to all those topics. And one more thing I forgot to tell you is there is no limit on the subscription. It's not that as one client I can subscribe only to one topic. Now I will show you. I'm subscribing to the topic called temperature, TEMP. Humid is another topic I'm subscribing. You see the list of subscriptions that are coming here down. Soil moisture. So 3 topics I have subscribed. So I request some of you to take one topic and send message to me. So let me see whether I receive it or not. So one of you send some message on the topic called temp, TEMP. One of you send message on the topic called humid, HUMID. Someone send the message on topic called soil moist. Let me see if I'm receiving it. You can very well see the topics here on my screen, all in lowercase. Somebody has published can be measured using sensors under the topic called temp. I don't know your client ID. I don't know your IP address. I don't know from which part of the world you are sending this message to me, but still I'm able to receive it without any delay. Somebody published on the topic called humid. Can somebody publish on the topic called humid? Nobody? Under the topic called humid, somebody published as good. So similarly, if somebody publishes on the topic called soil moisture, I will get that data also. So this is how MQTT protocol is working, and MQTT is very powerful for IoT because it's so ceaseless, easy, less latency. As you've seen, on that table that we had filled. It has all the advantages and it has covered all the disadvantages from other protocols as well. So with that, I'm winding up my session. If you have any doubts, you can ask me. No doubts? If you have any doubts, you can ask me. Okay. Host, I think we can wind up.
Yes, sir. Let me wind up the session, sir. Participants, if you have any other question, means you can ask. Sir, we will wind up the session, sir.
Yeah. Yeah, okay.
Yes, sir. Kind words are short and easy to speak, but their echoes are truly endless. I hope that his echoes are truly endless for us by this wonderful session. In this way, like to thank our today's resource person, Mr. T.N. Raj Vignesh, IoT Solution Architect, Catalyzing Enterprise Digital Transformation, Director at Saliabs LLP and Dialogue Solution LLP, Salem, for providing a wonderful practical session on the topic of introduction and configuring a LoRaWAN gateway and a real-life scenario of IoT in agriculture using LoRaWAN. Thank you so much, sir, for providing this wonderful session.
Thank you, Bhaskar. Thank you.
Yes, thank you, sir. Dear participants, the day 5 session 2 attendance and feedback link is posted in chat box. So kindly fill it soon. It will be open up to 30 minutes only.